Hello students, good morning. Today we will learn two more examples uh, on the basis of Ohm's law. On the basis of Ohm's law. The first example, if a 6.3 volt bulb draws 0.3 ampere current, find the resistance of the bulb. If a 6.3 volt bulb draws 0.3 ampere current, find the resistance of the bulb. So here voltage of bulb is given. It is a 6.3 volt, that is V is equal to 6.3 volt. Okay, the working voltage of a bulb is 6.3 volt and it draws 0.3 ampere current. Means current through the bulb is, current passing through the bulb is 0.3 ampere. So I is given, I is equal to 0.3 ampere and V is equal to 6.3 volt. Then use Ohm's law. We know that R is equal to, according to Ohm's law, R is equal to V upon I. R is equal to V upon I. That is 6.3 volt divided by 0.3 ampere. That is equal to 63 divided by 3. 63 divided by 3. Decimal point will shift here. Here also the decimal point will shift here. 63 divided by 3, that is equal to 21 ohm. 21 ohm. That is the resistance of bulb is 21 ohm. Okay. So then we will study the next example. Example number 2. Suppose a lamp or LED is to be connected on a battery eliminator circuit for indication of on-off condition. A LED is to be connected to the battery eliminator. If the battery voltage is 6 volt, that is the voltage of the battery eliminator is 6 volt and maximum current through LED is 10 milliampere. The maximum current through LED is 10 milliampere. Then how will you connect this LED? How will you connect this LED? Okay, so if we want to connect LED across the battery eliminator or across the battery, then we require one resistance which is to be connected in series with LED. Which is to be connected in series with LED. LED च्या series मध्ये एक तुम्हाला रेजिस्टन्स जोडावा लागेल. डायरेक्ट LED जर तुम्ही कनेक्ट केला तर तो जळून जाईल. म्हणून त्या ठिकाणी एक सेरीज रेजिस्टन्स करंट लिमिट करण्यासाठी एक सेरीज रेजिस्टन्स म्हणजे LEDच्या सेरीजमध्ये तुम्हाला एक रेजिस्टन्स लावावा लागेल, जोडावा लागेल. ओके, हियर अ सेरीज रेजिस्टन्स R is required to limit the current through LED. So the value of this resistance can be calculated according to Ohm's law. According to Ohm's law, R is equal to V upon I. So we know the voltage. Voltage is given. We know the voltage of battery eliminator and it is given as 6 volt. So voltage is 6 volt. V is equal to 6 volt and current passing through the LED is 10 milliampere. That is I is equal to 10 milliampere. So 10 milliampere. So see here, V is in volts. V is in volts. V is equal to 6 volt. So we have to convert this current which is in milliampere into ampere. So 10 milliampere is equal to 10 into 10 raised to minus 3 ampere. So R is equal to V upon I, that is 6 divided by 10 into 10 raised to minus 3. Okay, and that is equal to, आता हे 10 raised to minus 3 आपण जर वर घेतले तर 10 raised to plus 3 म्हणजे 1000. So 1000 into 6, that is 6000 ohm divided by 10. 0 0 cancel and therefore the resistance is 600 ohm. Okay, so we require 600 ohm resistance which is to be connected in series with the LED. Okay, so these are the two examples. Now we will study about sources of electric power. Sources of electric power. sources of electric power. Sources of electric power means which are the sources from which we get electricity. Which are the sources from which we get electricity or electric power. Okay, so there are mainly two types of sources from which we get electricity: AC sources and DC sources. Okay, AC sources provide AC voltages and DC sources provide DC voltages. Okay, so the main function of this source is to provide power to the load, which provides power to the load. AC source supplies AC power to the load, while DC power supplies DC power to the load. Okay, the AC voltage source provides the changing or varying voltage. Okay, so this is AC. So this is AC is not constant. It does not provide steady voltage. The AC voltage varies in accordance with time. In accordance with time, this AC voltage varies or AC voltage changes. It becomes maximum, then it is called as peak voltage, and voltage at any time it is called as instantaneous voltage. Okay, instantaneous voltage. And if we measure AC by multimeter, AC voltage by multimeter, then multimeter gives us RMS voltage, VRMS. We get RMS voltage which is measured by multimeter, and average DC, average voltage can be calculated by with the help of multimeter. Okay, then DC, this is a DC. DC means it is a unidirectional current. AC is a bidirectional current. It has two half cycles, positive half cycle and negative half cycle. And DC is unidirectional, means the current direction is in only one direction. So it is a steady voltage. This is not steady voltage. It varies according to the time. Okay, it has a frequency. So there are 50 cycles in 1 second. So it is called as 50 Hertz. Frequency means it is the number of cycles per second. It is called as frequency. Number of cycles per second. एका सेकंदामध्ये 50 सायकल्स तयार होतात. 50 Hertz. This is the frequency of AC line voltage. Okay, and from battery we get a steady voltage. It is called as DC voltage. Any battery has a specific voltage. For example, 6-volt battery, 9-volt battery, 12-volt battery, etc. Okay, so DC voltage source provide unidirectional current, and its magnitude is steady. Some of the common DC sources are battery. Okay, from battery we get DC voltage. Then from DC generator we get DC voltage. Then from rectifiers. Okay, rectifiers, there are 3 types of rectifiers. So AC rectifiers converts AC voltage into DC voltage. AC is applied to the input of rectifier, and we get DC output voltage across the rectifier circuit. Okay, so mainly there are 3 types of rectifier circuits: half wave rectifier circuit, then full wave center tap full wave rectifier circuit, and full wave bridge rectifier circuits. And in rectifier circuits, diodes are used. Then capacitor is used for filter circuit. In filter, so filter circuit filters the filters DC. That is, it separates the ripples in the ripples. It separates ripples from the pulsating DC output. The output of rectifier is pulsating DC, which contains some ripples or some AC component, some fraction of AC. that fraction of AC part, it is called as a ripple. Okay, some part of AC, it is called as a ripple. So this ripple is separated, or it is bypassed by using filter capacitor. Okay, and then we get a pure DC or steady voltage, and this is from filter we get a steady DC, and it is then given to the regulator circuit. So regulator circuit regulates the DC. That means even there are variations in AC fluctuations, there are variations or fluctuations in AC, then also this regulator provides DC output voltage constant. Regulators provide DC voltage which is a constant voltage, and it does not change even if there are fluctuations in AC, 10% fluctuations in AC, or also even load current changes, then also it keeps the output voltage constant. This is the function of voltage regulators. So these voltage regulators maintains the DC output voltage constant. Okay. Now we will see some DC sources, for example batteries. Okay, so these batteries are of mainly two types of batteries we use. Primary cells, this is a primary cells or dry cells. These batteries provide DC voltage, and second type is secondary cell. Primary cell and secondary cells, these are the two types of batteries. Okay, this is a most common source of DC voltage, and a battery consists of a series of cells. Battery means it is many cells are connected in series. It is called as battery. Okay, suppose this is one cell, and then if we connect another cell, then it becomes battery. This is positive terminal and this is negative terminal. So when number of cells are connected in series, then it becomes a battery. Okay, battery consists of a series combination of two or more cells. Okay, a cell is a device which converts chemical energy into electrical energy. Cell converts chemical energy into electrical energy. There are two types of cells, primary and secondary cells. The primary cells cannot be recharged. Any dry cell, it cannot be recharged, but the secondary cells can be recharged, or the secondary cells are rechargeable cells. Okay, the battery used in automobile vehicles, these are the secondary cells. Okay, a lead acid battery. Okay, or batteries used in for inverters, these are also rechargeable batteries. Okay, on dry cells which are used in torch, these are the dry cells, these are the primary types, and these batteries cannot be recharged. Okay, then second DC source, DC generator. This is quite different from battery. Okay, DC generator is different from battery. It provides DC voltage, but it is different from battery. It has a rotating shaft. It has a rotating shaft to which coil is wound. Okay, there is one rotating shaft which rotates in circular form. Okay, and on which there is a coil. Coil is wound on that shaft. It is called as armature. It is called as armature. So when this shaft is rotated at some specific speed by some external device, then the coil on the shaft also rotates. Okay, and with the same speed, this coil is kept in it is kept in a powerful magnet or in powerful magnetic field, and which cuts the magnetic flux and thus generates DC voltage. So when the shaft rotates, then it cuts the magnetic field of magnet. Therefore, it produces change in magnetic field or change in magnetic flux, and due to change in magnetic flux, DC voltage is generated across the coil. Okay, then The next source of DC, DC source is a rectifier type DC supply, rectification type DC supply. So this type of supply is commonly used in our electronics laboratory. Okay, DC power supplies, which consists of transformer, then rectifier circuits, then filter and regulator. So transformer changes the voltage level from 230 to for our requirement. Suppose generally a step down type transformer is used. If we want 9 volt DC, then we use 9 volt secondary volt transformer. Okay, its secondary voltage is 9 volt 500 milliampere. Okay, or 300 milliampere. So we put in rectifier circuit that rating of the transformer. For if we want 9 volt, then we substitute there 9 volt secondary transformer. If we want 6 volt, then we put there 6 volt secondary transformer in a rectifier circuit. Okay, so there is one step down transformer, then a rectifier circuit which consists of diodes. In folio rectifiers, bridge folio rectifier circuit, 4 diodes are connected. In half wave rectifier circuit, only one diode is connected. Then output of that output of that rectifier, it is given to the filter circuit. In filter circuits, electrolytic capacitors are used. So capacitor pass AC and it blocks DC. Therefore, it filters this voltage, and then it is given to the regulator. So in regulator regulates the DC voltage. It keeps the DC voltage constant. Okay, so in this way, such type of regulated DC power supplies are used in our electronics laboratory. Then next voltage source is alternators. So alternators are also called as AC generator. Alternators provide AC voltage. Alternators gives AC voltage. So it is also called as AC generator. It is quite identical both in construction as well as in mode of operation to the DC generators. So DC generators and AC generators are nearly equal, nearly same. Only the DC generator rectifies that voltage generated with the help of brushes, and then we get DC voltage. The construction is same for AC generator and DC generator. So when its shaft is rotated, the coil wound on it also rotates. The coil which is wound on the shaft, it also rotates, and with the same speed. And as the coil is made to rotate in the magnetic field of permanent magnet, then it cuts the magnetic flux, and an alternating voltage is or AC voltage is generated across its output terminals. Such alternators or AC generators are commonly used in most of the electric power stations. Okay. The next AC source is oscillators and signal generators. Oscillators also provide AC voltages, or signal generators also provides us. These signal generators are used in our electronics laboratory for testing different electronic circuit, for testing amplifier circuits. That is the signal of signal generator. AC signal is injected, or it is connected to the input of the amplifier, and we can test the amplifier circuits, or for testing different electronic circuits. Signal generators are used, and oscillators also provide us AC voltages. Okay, so an oscillator is a circuit which provide an AC voltage with a desired frequency, and this frequency is mostly used in the laboratory for testing amplifier circuits. Okay, and other electronic circuits. The frequency of the oscillator can be changed as per our requirement. The frequency, if capacitance varies, then the frequency also varies. If capacitance is changed, then frequency changes, because there is a formula for frequency. F is equal to 1 upon 2 pi root LC. 2 pi under root LC. L means inductance and C means capacitance. If L changes or if inductance changes, then also the frequency changes, or if C or capacitance changes, then also the frequency of the oscillator changes. Okay. Then a signal generator is an instrument which consists of an oscillator and it also consists of wave shaping circuit. These are capable of giving sinusoidal or sine wave voltages. Along with also these signal generator generates non-sinusoidal signals like square waves, triangular waves, sawtooth waves, okay, rectangular waves, etc. Okay. Then the next AC source is inverter. So inverter also converts DC voltage into AC voltage. Inverters converts DC voltage into AC voltage. Okay. So we will stop here.